Hi, we are working on the 10A Part 2 notes, and this is example number 6. And just like the ones we've been doing up till now, the problem is asking us to set up the trig ratios by identifying sine, cosine, and tangent of the angle theta. And so when you do a problem like this, it's a good idea to just write down what it is the problem is asking from us. The sine, cosine, and tangent of theta. And when you set that up, again, we're not always just going to give you those templates like you saw in examples 1 through 4. Instead, you can just write your own, just like I'm doing now, okay? So we've got our little template here. We're reminding ourselves what SOHCAHTOA is. You're going to write this as well on your problem. And then, of course, the next thing you're going to do is you're going to say, I need to label my triangle by identifying where the angle theta is, and then marking my triangle accordingly. Of course, that long diagonal is our hypotenuse. The side touching theta that's not the hypotenuse is our adjacent side, and the one all the way across, of course, that is our opposite side that we label with an O. All right, we're all labeled now, and we are noticing that we have side lengths for our adjacent side and our hypotenuse, but for our opposite side, no. So now what we need to do, of course, is to use that Pythagorean theorem formula, and we need to find out what the length of that missing side is so that we can have all of our sides to fill in our trig identities. And here's that formula to find the missing side. You're going to remember that A and B are legs. So that means the same thing as leg squared plus leg squared. And C, of course, always the hypotenuse equals the hypotenuse squared. So our legs, of course, are those sides that are making up that right angle. Here we have 6 squared plus, where's our other leg? There's that x squared. Those are the legs. The hypotenuse is 9. That's 9 squared. And then to solve this, we'll go ahead and we'll do our 6 times 6. Do it in your calculator. Check yourself. Okay. Our 9 times 9, of course, you can just square it using your little square function, is going to be 81. So we're going to have x squared plus x squared equals 81. Now, because these are being added together and this is positive, you can subtract this, because this is x squared plus 36 or 36 plus x. It doesn't matter the order. And when we subtract that 36 from both sides, 36 minus 36, of course, is going to give us 0. We don't need to write that. We'll bring the x squared down. And that 81 minus 36 is going to give us 45. Okay? 45 is not the number we're looking for. We're looking for x, which would be the length of that side. So in order to find what that would be, we have to take the square root of both sides. The square root of x squared is just x. The square root of 45, what's that? Well, we can check our calculator to see if it's a perfect square. And the way you do that is you just take 45 and you do the square root. And if you get a decimal, you know, not a perfect square, okay? But we can do our simplifying here. Of course, this ends in a 5, so I'm going to start dividing by 5. And I know that 5 goes into 45. Of course, you can definitely pull out your calculator and divide by 5. And you're going to get 9, okay? This is a prime. 9 is not a prime. It can divide out to 3 times 3. And so there's our prime factors for 45. And if we have a double like we do with the 3, those 2 on the outside can pop out as 3. This 5 doesn't have a buddy. So this would simplify to 3. Again, 2 on the inside, 1 on the outside. Root 5. The 5 doesn't come out because it didn't have a buddy. Okay? So then the length of that missing side up there, we can put as 3 root 5. Now, if you leave it as root 45, I won't count that wrong. But especially for those of you guys moving on to Math 3, I really want you to be in the habit of simplifying those radicals. Okay, so 3 root 5 is what we found out was the length of our missing side. Okay, the sine of theta is the opposite side over the hypotenuse. Here we've got the opposite side, which is 3 root 5, over the hypotenuse, which is 9. Now we can see here that we can simplify this. We have a 3 on top and a 9 on the bottom. That means that we can cancel the 3 with one of these. Okay, so what that looks like, 9 is the same thing as 3 times 3. And so one of those 3's can cancel with one of those 3's, and that'll leave us with root 5 over 3. Okay? This is all about finding that missing side length and then simplifying those terms. So the cosine of theta, we know, is adjacent over hypotenuse. Our adjacent is 6, and the hypotenuse is 9. Now we know that 6 is the same thing as 2 times 3. 9 is 3 times 3. We're going to cancel one of those 3's, and that will give us 2/3. Now, I'm not going to count this wrong, but this really is the much better answer to reduce those fractions. The tan of theta is the opposite over the adjacent, opposite being 3 root 5, adjacent being 6. And when we simplify this, we know that 6 is the same thing as 2 times 3. So this 3 and this 3, and up 3 and a down 3, of course, will cancel. 3 divided by 3 is 1. That's why they cancel. That'll leave us with root 5 over 2. And there's our tan right there. Okay? All right, guys, just remember, when you get an answer for these ratios, try to simplify it. All right? Thanks for watching, guys.